Okay, so this section is on cycloalkane, so we're going to be dealing with rings. If we have very small rings, like 3 carbons, we get a 60-degree angle. And we know that the tetrahedral carbon would like to have 109.5 degrees because it's an sp3 hybridized carbon. And so we find that a 3-carbon molecule, 3-carbon ring is very unstable. Thus we have very high heat of combustion. 4 carbons is a little better, but 5 is really good. And 6 is our lowest, most stable form. When we look up here, we see a 6-membered ring has an angle of 120. However, the ring is not flat, and that's why it's the most stable. So here's our hexane. We've got 6 carbon atoms in a ring, and as I turn it this way, you'll be able to see that it's not a flat ring. If we look down, pick 2 carbons to look down the barrel of, look at this carbon and the carbon behind it, and get them lined up, you can see that they're all in staggered conformation. We've got this one, the red one that's up, this one's to the side, but they're not any of them on top of each other. And the same thing goes on the other side. They're all staggered. Now this ring is able to flip and move around. It can also be in a boat configuration. This is hexane in a boat. And if we look down, we pick 2 carbons to look down, we will see that these are eclipsed. The red one is right behind, the red and white are right behind each other. So they're eclipsed. The other problem with our boat formation is that we've got steric hindrance here at the top. These, particularly if they're large groups, get in each other's way. So the boat conformation is less stable. The conformations of cyclohexane. So it's important to remember that in solution, cyclohexane can bend and flex. It's not always sitting in exactly the same conformation. It can move and twist. So it can be in a chair configuration, or it can be in a boat configuration. The boat configuration is going to be less stable. If we look down these 2 hydrogens, we will see, these 2 carbons, we'll see on the Newman projection that the hydrogens are eclipsed. We also see that there are flagpole interactions. These hydrogens, particularly if they're large groups, not hydrogens, but if you put another substituent there, they bump into each other, making the boat less stable. If we look at the chair in a Newman projection, we see that if the carbons are right behind each other, this is our ring, 1, 2, 3, there's a carbon behind, 4, 5, 6. We get all the hydrogens, all the groups, are in a staggered configuration. So that makes the boat more stable. We can graph the energy of all these twists and turns. We start, the lowest energy is the chair, because we said that was the most stable. The half chair is the most unstable, with the boat being somewhere in between. So the boat form will twist to relieve the strain, and it'll twist and it'll end up in the chair.